Welcome to Upstack America's IT training programs. My name is Bob and I'm the IT training lead for Upstack America. Today's training is on data science and specifically on artificial intelligence and machine learning. Our trainer will take us through today's session is Paul DeBacker. Paul is a data scientist with outstanding work experience managing digital transformation projects on artificial intelligence and machine learning. He also holds extensive experience as a solution architect for robotics process automation, and also he has experience as a developer for robotics process automation. Paul holds a Master of Science in Artificial Intelligence and Machine Learning from the University of Texas in Austin. He also holds a first-class honors Bachelor of Technology degree from Anna University, Chennai. Thank you for watching and we hope you will enjoy the training.
So last week we studied about we got to see different aspects of data science, right? So this is we're gonna continue from where we left last week on session 2. So on session 1 we spoke about the data science approach, and first we spoke about the uh, introduction to Python, right, where we saw certain practical hands-on of very Python basics in Python, like what is a dictionary, what is a tuple, what is a list, what is a uh, you know what is a string, what are the various data types, right, and how do you play around with it, what is a dictionary, what is a key value pair, what is indexing, how do you deal with string, how do you deal with text files, kind of the very basics that in addition to what you have gone through in Udemy. And then on the second session we did see about the introduction to data science. What does data science comprise of, what are the various approaches or pipelines in data science and things like that, right? And then we saw two things. We saw certain we saw what is artificial intelligence or AI. We saw what is machine learning, that is ML, right? And then we saw the different types of machine learning, right? We spoke about something called as supervised. Spoke about something called as unsupervised, right? So Kevin, just to kind of see, so do you remember or recall what did we exactly, what was the concept behind the supervised and what was the concept behind unsupervised type of machine learning? If you can just quickly, just a one-liner, what did you understand, or just to make it a little interactive here.
Supervised was when you have more than one independent variable and one dependent variable. And unsupervised was more than one independent variable and more than one independent variable. So that means we had more than one X, one Y for the supervised, more than one
Yeah.
X and more than one Y for the unsupervised.
Yeah, so little correction. So for the supervised learning,
Mm-hmm.
okay, we saw that, yeah, this is my supervised learning. So in supervised learning, we saw that I can have multiple independent X as my input factor, which helps me to compute or calculate my Y, which is also called as the target column. That's what we discussed, right?
Yeah.
So if we, yeah, so all X values will help me or will allow me to identify what, or allow me to predict what is the Y. So if I want to predict an employee's, or let's say we took an example of a college campusing salary offer prediction. So let's say we saw that we had three different axes. We had the GPA score of different students, okay, we had the year of passing, and we had the domain, and we had certain values in dollars which was already been given to certain students in the past history. So this is my history of the data of last 5 years of campusing, let's say from the university, based on which I'm trying to predict what will be the average package of a student of having similar categories for 2021. I want to make a model to perform a prediction where I'm passing the age, let's say the year of passing, the GPA that the student has got, and the domain, whether it's from IT or aeronautical or mechanical, and what was the, let's say, $2,000 was offered it to a guy of this same characteristics in last year or few years back. So we take this and various other examples to train my model, and I want to make a prediction that anybody in 2021 batch having any of these attributes as a feature, what could be the predicted salary that a company might offer him or her. So that was my supervised learning, where I have my x's along with which my y is also supplied. That means my model would also get a flavor of what is my output or what is my target variable. Okay. Okay. Yeah. So now, then, so supervised learning, it's independent variables, one target column. Okay. Now in supervised, what we saw in unsupervised learning, we saw that we might have almost x's like x1, x2, x3, but I do not have any y. I do not have my target column being exposed to my model. So data is taken as a whole except my y. Okay. And then in supervised learning, we generally try to cluster our data in various categories and create clusters and see where are my data points falling. So now you might ask, what is a data point? Now let's say when we represent a specific value of data in a graph, we call it as data point. Now let's say I have a student who has a GPA of 98%, okay, is from the domain of information technology, and pass out year is 2017. Now with these three attributes, I'm trying to calculate I'm trying to cluster the student and see in which cluster the student falls. So let's say the student is falling somewhere here. So what is this called? We call this dot as a data point. So this data point is nothing but it is a representation of that student in a mathematical space or a graph. So when you replicate an entity or a data with certain attributes and plot them into a mathematical space or a graph, we call that dot as a data point. So this single dot, which is, let's say this guy's name was John, right? So that means when I plot this information in a mathematical space, this dot which is here is representing this student called John actually. So when I convert the attribute or the information into a mathematical space and identify the attribute or the entity as a mathematical dot in a mathematical space, we call that point as a data point. So like this, all the students would fall in either of these blocks in any of my four quadrants. So that means whenever I plot anything on a mathematical space, each student is becoming my one data point when I cluster them. Okay. Then, so this was what we saw about supervised and unsupervised learning. Supervised learning types generally goes with regression model and classification model. Regression model is nothing but when we are trying to identify mathematical values. So we saw that if I want to plot certain values and I have a regression line, we call this as a best fit line, and I might have my data points across both sides of the best fit line, right? And then when I try to calculate, and then when I try to calculate the distance of one point from my best fit line, right, then based on that we identify how much different is that specific data point from my best fit regression line. We will learn more about regression algorithms later. Then classification is another type of a supervised learning. Let's say I want to classify. I have a lot of customer information, right? And sales information, and I have to classify. I have a classification column, let's say good customer or bad customer, right? Based on certain attributes, I want to classify every customer of mine. So let's say I have a new customer who has enrolled yesterday, or I have a new customer in place. So when I give all these inputs, I want to categorize and see what my model predicts, that whether this new customer falls into the good classifier or acts as a bad customer. So this is what is a classification problem. Okay, now there are other classification problems that you might come through. So let's say one of the common classification is, you would have heard about email spams, right? That you receive emails, so you receive spams as well, correct? Now if you go to your Gmail, as I showed you, Gmail classifies any incoming mail into three categories by default. One is personal, I think another is social, and the other category is, I think, others. So any incoming mail in your inbox gets automatically classified into three different sectors, categories. Now this is how the Google's Gmail model has been trained on certain data, that even though it identifies any mail that comes in, it would identify whether it would fall here or here or here. Now sometime what happens, let's say you receive any job offer, or you receive any email which is, let's say, of a job marketing or a job offer or anything like that. So Gmail model might identify that, okay, it might be a marketing ad email or it might be a offer related email. So it might, classify and send your email into this others category. But let's say you have really applied for a job and you got an email, and that email is not in your personalized inbox. So what we do, we go and check the social tab in Gmail, or we go and check the others tab in the email. I exactly forgot what are the tabs. So I think it's personalized, social, and the third one is others, or it's something else. So it's primary, sorry, it's not personal, it's primary, social, and promotional. So let's say when you get any company's offer, your email might land up into the promotional tab because the algorithm might would have classified. So that means then you say, oh no, this is my valid email that I've got. Then you move that to your personal or primary email, right? So that means the input email that has come in was misclassified by Google's algorithm. So that means, so on an in a data science world, it's not at all possible that every model will give you 100% accurate prediction. So even Google would have trained the model into a huge amount of data, right? Huge amount of data set. But let's say I am a company who is based out of somewhere in US, and I have sent you a job offer. So Google's model might classify it as a promotional email, so it might not put it into your primary inbox, it might put it to your promotional. Or sometime if it finds that it is coming from an unregistered domain or something, some email directly goes to my junk folder as well, right? So let's say I send you an email from an unregistered domain, though you know that I'll send you an email, you don't find it. What do we say? Please go and check your spam folder or junk folder. That means there also the algorithm would have identified some attribute of the mail that it classified it as a junk, though it is not a junk. That means the model has misclassified it. So similarly, like this, we have any model that goes make some sort of an error. Like human are prone to make errors, even models or the digital models that you create are prone in making errors, right? Any questions till now on this, Kevin?
No, I'm good.
So today we're going to talk about a very important aspect. I'll just move to the next slide and then come back. Is people generally confuse between these three domains called data science, artificial intelligence, and machine learning. So this diagram will, if you also might have a similar kind of a doubt, it will clarify you. So what happens exactly is, so data science is nothing but, data science is the entire universe of what we call it as, so data science is actually my entire world which relates to data. So any analysis or computer branch or study or analysis or research that happens with respect to data, that entire part or the entire world is represented by data science. Inside data science, so I can say, or you can say, data science can be the parent domain, is the parent domain of all the data related subdomains, inside which AI or the field of artificial intelligence is the next subdomain. So data science is my entire world, out of which the 1% is the 90, let's say 9% of the analysis that goes into data science is contributed or falls under the field of artificial intelligence or AI. Now, what is AI? We have understood this last time, right? So we saw, so we discussed about what is an artificial intelligence, right? So whenever we have real world data set, we create a model to learn some sort of a hidden pattern, and this pattern is utilized by a computer similar to an human intelligence to decide. We call that machine as a AI equipped system, right? Where it has the resemblance with the human excellence, the human brain or the human neurons, the how a human takes decision. Now, in the field of AI, whenever we talk about the domain or the research or the work which is related to data, processing of data in a mathematical space, and we try to analyze the hidden pattern and see what this data is telling to me, is the field or the study called as machine learning. So here your job is only to work with data and see what is this data telling to me, create a mathematical pattern by various models, using various models rather, and see what is the data telling me. Like we perform classification, we perform regression, we create clusters. All these things are the outcome of a machine learning exercise, right? And then now your question is, what is deep learning? So deep learning is nothing but, okay, okay, so that's what we would be reading about here. So if I go with the textbook's definition, so artificial intelligence and data science are a wide field of application systems and more that aim at replicating human intelligence through machines. AI represents an action planned feedback of perception. So that means whatever data is giving a hidden analysis or is identifying the hidden pattern, it is able to take a decision. So when we equip a system or an application which can replicate human thoughts and decide by itself, we say that it's an AI based engine. So this entire parent domain is called as data science, out of which human intelligent replicating systems are called as AI. So we have a perception, we have a planning, we have an action, and then we have a feedback. Now, what is this? So data science uses different patterns, parts of this pattern or loop to solve specific problems. For example, perception. Data scientists try to identify patterns with the help of data. That means I build a perception. What is this data telling? So if I, as we took the example that I have a data with 3 columns, let's say student CGPA, okay, branch of study, year of pass out, okay, and salary. So whenever you see this data, your brain is able to detect that, okay, this is the data which might be telling me about a student's annual salary given or offered it by a company based on his or her academics, right? So you would be able to decide that this data is giving me this information. Then you go and apply drill down. So let's say even this data is given in Excel, then you want to identify, okay, how many students have passed out in 2019. What will you do? You will go to Excel, you will open the filter category, you will filter this data and choose only 2019, and in Excel we can see what is the count of the students who have graduated in 2019, correct? We can do that in Excel, right? It's a basic operation in Excel. You can filter it out and see. So based on that, you build up the perception, and then you dig deep and do some, then you might say, okay, in 2020, I see there are 100 students that have graduated. So what is the average salary that was offered? What will you do? You will first filter the data in Excel with 2020. Now you have the list of salary. Now what will you, even in Excel, if you keep the cursor, automatically you can see at the bottom what is the average value or what is the sum. But if you want to calculate in Excel, what will you do? You will take the sum of all the salaries of the 100 students divided by 100. So you get the average salary, let's say $1,000. So you now came to a conclusion from the whole data. So I gave you 5 years data. You were interested to know something about only the 2020 students and what was the average salary. So what you did 2 steps. You filtered on 2020 and then you took a sum, divided by 100, you got the average. So this was the hidden analysis. So now if I say $100, $1,000 was the average salary, that means you did a very basic operation on this data and derived this information. But this information has come out from the data itself, right? That means this information was there here, but it was hidden. My data did not tell me that what is the average salary of 2020 pass out students. I did some activity or action and calculated this. So this is a derived value. Yeah. So this is a value which has been derived from here, right? So this was hidden. You did some calculation to find out what was the average salary of the 2020 students pass out, and how many students pass out. You just filtered out and find out the count is 100. So this way we build up various kind of hidden analysis from the data. This exercise is called as machine learning. We try to find all possible solutions, find the best solution, and data science creates a system which integrates both the world of AI and ML. Now when we go about this step, now you might have a question that, okay, we understood all these things, we understood what is a machine learning and what is kind of this, but what is my deep learning? So deep learning is a advanced version of machine learning. The first thing is, whenever we apply deep learning, so whenever you have a large number of data set, okay, so let's say I have given you a classroom data or 5 years data of my campusing. So 5 years data, let's say the total number of rows in my data is, let's say 10,000, which is very very minimal. It's manageable. So this amount of data can be processed by yourself and you can bring out some analysis, because 10,000 data is not a huge amount. So in this we apply machine learning. Now let's say I give you a college data of, let's say, 20 years. 20 years of my students data if I give you, let's say, which comprises of 1 lakh records. So compare, if your 10,000 data set, whatever the pattern might be, it will be more complex when I give you 1 lakh records, because the number of data is more here. So if this data is giving me, let's say, 10 insights, this data will give me 100 insights because the data is more. Now to compute this huge amount of drastically increased data, you need to have a stronger computational or modeling power. So to handle large amount of data set and analyze different hidden patterns, we utilize not the machine learning, but something called as deep learning methodologies or algorithms, which are an advanced version of machine learning. So we will learn more about deep learning at the end of our course, because it's the advanced version. Okay, but till now you can have a very basic or a lame understanding of what is deep learning. Now is it clear to you? This, it will be very confusing when you are into this data science world. People often confuse with AI, machine learning and data science. They don't know which falls in which category. So I hope this explanation is able to make it clear to you. So any questions on this, Kevin, till now?
Not at this point.
Okay, you will understand, right?
Yeah.
Okay, perfect. Ready. So now, so this is the next slide which talks about deep learning. So see, it will tell you the same thing. So deep learning is just a subfield of machine learning that is concerned with algorithms inspired by the brain structure. And yes, so what happens, one more thing is, deep learning mostly, so whenever you want to involve the concept of AI along with your large amount of data set, your deep learning comes into picture. Okay, machine learning is nothing but deals with data and tells you what is the hidden pattern in your data. But when you want to understand the algorithm and then you want to see how it would react as a part of your human intelligence, there also we apply the concept of deep learning. We call it as artificial neural network. We will learn more about it later. So a computer model can be taught using deep learning to run classifications like pictures, text. Yes. So now the basic example that I can give you is, now whenever I give you the college data, it was not having that much a human visual or sightal representation. It was just a number where you want to see how many students got average salary. But now let's say I give you 2 lakh images of my 2 lakh images, and I ask you to classify what are the categories of those images. Are the images of dogs? Are the images of cats? Are the images of an elephant? Are these the images of a tiger? Now, whenever it comes to any visual appearance, visual appearance or visualization, it's a area linked with human intervention, human intelligence, or how the human identifies. So that means if I give you 20 images and ask you to tell whether you have a dog in this image and you have a cat, it will be easy for you, right? So you take one by one images, you will see, because your brain knows how does a dog looks like, how does a cat looks like. So you'll be easily able to identify. You will say, hey Paul, no, this image there is no dog. Hey Paul, this image there is a cat. Hey image, this image has both dog and cat, because you are able to visualize through your eye and using your human intelligence, because your brain knows the structure and the attributes of a dog and a cat. Now similarly, when I have to create a model which would predict on your behalf utilizing human intelligence that whether an image is a dog, is having a dog or a cat, I have to feed it with the human intelligence capability. That means I have a huge amount of data set, which 2 lakh data set, if I give you now, it will take years for you to finish as a human being, right? But it is not possible also for you. Now you will say, okay, let me create a human model which is human intelligent enough to tell Paul whether it's a image of a dog or a cat or both. So that means your model is a representation of your human intelligence. So in that case, whenever we have human intelligence capability related use cases, we apply a deep learning technology, which is an advanced machine learning model, which acts similarly as how human brains. So 90, every decision or everything in our brain works through neurons. We'll learn more about it. Okay, and this is how our brain gets connected to each and every neuron in the brain. So similarly, when we create deep learning models or exercises, we deal with neurons which acts as human brain representation. So these neurons developed are capable of taking decisions as similar to as a human. So now when I create a neural deep learning model and then I pass on this 2 lakh images, so what I'll do, so this 2 lakh images would be utilized for my model, deep learning model, to understand how does a dog look like and how does a cat. So first I have to train this neural network, which is, we call it as neural network, okay, in deep learning. So whenever I have to train my model that what are the attributes of dog and how a dog looks like, what are the attributes of a cat and how a cat looks like, only then whenever I pass any image from this 2 lakh, it will be able to identify me whether it's as a dog, whether it is a cat, or it has a both, just like Kevin did.
Paul.
So this entire concept is called as deep learning exercise. Sorry, is this Bob?
Yeah.
Okay.
When you say lack, what do you mean? Is it what do you mean by lack?
No, I mean it's 2 lakh images that I give you.
Yeah, but what do you mean by 2 lakh? Like, what is lack? Lack is what?
You say lakhs, millions. Let's say I give you 2 million images. Okay. So actually, yeah, sorry. Oh yeah, US, they say it million. Okay. So 10 lakh is equal to 1 million. That's the calculation.
Is that the Indian way of
yeah. Oh, that's my bad. Sorry. I should have used the term million. Okay. Sorry. So that's my bad. But here we mostly go with lakhs. So that's the problem. So it's 1,000 lakhs and then it goes to crore. So in US, it's million. So actually the calculation is 10 lakh is equal to 1 million. So if I give you 2 million images, it becomes computationally tough for you. So that's where I generally, then Kevin would say, okay, let me create a machine learning model or a deep learning model, which is equipped as a human intelligence capability. And then I will pass these 2 million images, which will be pretty much easy for me to decide whether this image is of a dog or a cat or both. So that much computation. Now, the problem is to process these 2 million images, don't you think you need that much amount of hardware as well? That means, let's say you are running 30 apps on your iPhone, your iPhone still doesn't hang, it performs smooth. Now let's say if I put 2200 apps at a time, there might be a certain lag in my iPhone, because it might have, so the computation or the the motherboard or the hardware would have reached its maximum threshold, okay, of, let's say, iPhone 10 could open 100 apps simultaneously without any lag. The moment you open 150 app in your phone, there might be a slight deviation into the, you might feel a latency in your iPhone, because you have exceeded the threshold, and it has exceeded the computational power of the system. So similarly, when I give you 2000, or let's say 2k data of a of any data, it is very easy for you to process. Even in Excel, you can load this much amount of data, right? But what is the maximum limit of an Excel? I think it supports maximum of 1.7 million rows in an Excel. More than that, you cannot put any data in an Excel. Now let's say I give you a data of 2 million, you cannot open this data in an Excel, because it exceeds the maximum number of rows that a Microsoft Excel supports. So similarly, when I give you 2000 images, it is very easy for you to classify using a normal, let's say, a hardware which has, let's say, 10 GB of RAM, 1 TB of hard disk, and all those things. But when I transform this to a 2 million images, your computational power also needs to increase. So both your hardware and your software has to support this much computation. So for software, it's nothing but the model. So your machine learning model cannot do that. So we go with the deep learning model, which is able to handle this much amount of data. And then to increase my computational power, I would need something called as GPU, called as graphical processing unit, which is more than my CPU power. So this is central processing unit, which is equipped with every system in the motherboard. But GPU is a graphical processing unit, which is much more computationally higher in, this thing, compared to your CPU. Let me just quickly show you one thing. I'm not sure if I have this open. Okay. So if I go to Google Colab, so Colab is a deep learning platform which is given free by Microsoft, my bad, by Google. So whenever you open anything in Google Colab, see, these are the various, this is how a Google Colabs looks like. So let me open this exercise. I'll show you. It's a deep learning research, deep learning exercise that was done. Okay. So the amount of data in it is huge. So that means this is the data of, we call it as, globally it is known as MNIST. So MNIST is nothing but it's a data set which, sorry, I think I opened the wrong one. Give me a sec. Okay, so this is one of the platform where you still can so when we create deep learning models, okay, so this is for proper computational purpose, we use Google Colab, because even my computer is not enough to train. Even if I go to my Jupyter notebook, okay, like I cannot utilize this model, okay, because it's computationally expensive and high. So this is how a model training happens. So I have trained a model on a specific thing, and I was trying to classify. So actually, this is the image data set. Okay, this has, I think, 16 million images, handwritten images. So there's a community in US who has taken different form of handwritings of people, that how differently a 9 can be written, a 2 can be written, a 5 can be written, a 6 can be written. Okay, based on this, they have identified images of the digits, okay? And then a model, I'll show you this tomorrow. I'll have to run this now. If I run, it will take a lot of time to process. I'll keep it ready tomorrow to show you as an example. I'll run it beforehand. So when you run this much proper heavy algorithm, so Google Colab gives you a process called as the GPU concept. So I have to enable my GPU. So what do I do? There is an option. I'll go to edit, notebook settings. See, this is a setting where I have to enable whether I need a GPU or I need a TPU. TPU is for more computational power, the highest that is available in the market. Okay. GPU is graphical processing unit. So for me, GPU is enough. I think TPU, Google charges you for that. GPU till certain extent I can utilize it for free. So this GPU is an extra hardware on which this Colab notebook is running on a Google data center. This is not possible when I run this in my Jupyter notebook, because this Jupyter is running on my local system, which is here. So this is hosted on my local computer. So it is not possible for me to process that much amount of data. So I process it in Google Colab, where Google gives me a platform to kind of utilize GPU and deal with this much huge amount of data. Right? Okay. So yeah, coming back, any questions till now?
So Paul, when you're running the GPU, is your data stored in the Google Drive or is
Yes,
it stored
there are
on your
different.
computer?
No. There are different sources. So you can store data anywhere. You can store it in Google Drive. You can store it in OneDrive. There are various machine learning, data that are stored in the cloud by the machine learning community itself. You can directly make a Python command and pull the data from their cloud. You don't have to have the access to the physical data. You can directly pull in through a Python command. So it will load the data completely in your data set, into your exercise, or into your machine learning notebook. Okay. But yes, whenever we do basic simple exercises like Python, we might have the data loaded in my in an Excel, which I load into a Jupyter notebook. It is there in my computer physically. Now when I give you 16 million images, my system cannot hold it, right? So in that case, I have to call the data from a cloud from where it is saved. So there are multiple storages from where you can call in. You can call it from a Google Drive. You can call it from OneDrive. If the machine learning community has stored the data into some packages, you can call the package directly, which will load the data automatically into your Python. So these are the various ways that you can deal with it. Okay. So last week we spoke about the supervised learning and the unsupervised learning. So these are predominantly the top two approaches in any machine learning exercise. But now there is something which is, I would not say that it's less used, but it is also widely used concept, but not that prominently used compared to your supervised learning or unsupervised learning. So we call something as a semi-supervised learning. So what is a semi-supervised learning? So we know that in supervised type of learning, I have a data which is, having X independent variables, and I have my target column and my data. Whenever I have a target column, we call this as a data that is labeled. Remember these terms, it is very, very important. So whenever I have a column with Y in my data set, that means my target column is available. We call this data as a labeled data. But in unsupervised learning, we do not have this target column Y. We only have our X values, X1, X2, X3. So I do not have an exposure to my target column. So these are called as data which are unlabeled. So these are the two prominent terms that gets used. Data that is labeled will always have the target column Y in it. The data that is unlabeled will not have the target column Y in it. So that's in supervised learning, that's in unsupervised learning. Now what happens in semi-supervised learning? You have a combination of a labeled data and unlabeled data. So that means, let's say I give you a data which has, let's say 20,000 records. Okay. 20,000 data rows I give you, out of which you might find 5K records are only labeled. That means you have a Y value for them, and almost 15K records are not labeled. That means that row is having a Y value missing. That is called as unlabeled data for that specific row. So there are machine learning exercises that we do to handle the data which are missing. So when you have a similar kind of a data where your data is partially labeled and partially not, we call it as a semi-supervised kind of a learning exercise under the machine learning domain. So data are labeled and we perform. So we might go for a similar classification. We might go for a supervised kind of an approach where I want to draw a regression algorithm where this is my best fit line. These are my data points that are falling across the line, right? And I have classified or clustered it, but there are some which got misclassified. And there were certain portion of the data that was not labeled. That means we call it as unlabeled data. So this is what is called as semi-supervised learning. So yeah. So that's what is we are trying to approach here. So what is labeled versus unlabeled? So if in practical applications, your unlabeled examples, I'm ignoring this term called training. I'll come back to this later because there's a big part in ML exercises called training and testing. So we'll talk about this later. So whenever we have an unlabeled example, are readily available, but labeled ones are fairly expensive to obtain. I'll tell you why. Now, let's say you download 20,000 images of dogs and cats from Google and you save it in a folder. Can you tell me whether that's a labeled data or an unlabeled data? What does your sense of humor says?
That'll be unlabeled.
Absolutely. Because it's you, with part of your human intelligence, you know that you have downloaded dogs and cats images and stored it here, but a machine doesn't know whether it's an image of a dog or a cat or a tiger or an elephant. But so those images in terms of machine learning that I saved, those 2000 images are unlabeled, because there is no way that if I pass these images to a machine directly, it will be able to identify. So that's why it says that unlabeled data is very easily available in the world, whereas labeled data are very expensive to get, because you can get data which are unlabeled, but converting your unlabeled data into your labeled data needs some sort of an effort or a task, and it is expensive for that reason. Now, if you want to label these 200 images that you have got from Google, you need to compute those images through some machine learning formation or transformation and create a label for these images which can be utilized by a machine later to understand that, okay, this is how I differentiate a dog, this is how I differentiate a cat. But to perform a labeling on an unlabeled data is the expensive exercise in your entire machine learning. Now, there are multiple ways in Python, to create labels of different data. So let's say you have 10,000 datas of different players, football players. Okay. This is Messi. You can say this is Ronaldo. You can say this is Zidane, but a machine doesn't know. So what I'll do, I'll take, let's say, 500 images or 100 images of Ronaldo, and I'll label them as Ronaldo using some sort of Python programming. I'll take 50 images of Messi and I'll train the model. I'll label the data saying that these 50 images are of Messi. Okay. Now, then after this, when I pass a new image, then my model or the exercise will be able to detect whether it's an image of Messi or it's an image of Ronaldo. Because previously I have given some sort of a characteristic by labeling those images, from which my model has learned the hidden patterns to recognize that this is something. But there are certain examples of celebrities which are already being trained on certain huge data sets. Like Google has already trained a lot of top celebrities in the world's Like if you take the image of Barack Obama, okay, and you pass it on to a Google based model, it will be easily detecting that this is the image of Barack Obama, because Google has already trained this model on thousands of images of this person. So there is something called as tagging. Okay, we call it as a celebrity tag of images or global personality tag. Those are readily available on the internet that you can download and you can directly use. So these are the various types of data that can be available to you, called as label or unlabeled. Okay, then the another prominent part of machine learning is something called as reinforcement learning. So what does this reinforcement mean? So reinforcement learning is nothing but, let's say I have my input data, I have some sort of a processing or machine learning processing, and I have my output. Now what happens in reinforcement is, whenever I am giving an input to a model and I'm having an output, I'm trying to see whether this output is correct or incorrect based on certain parameters. Now, when my output is correct, that means my model performed well. I take a feedback from this output and give it back to the model as a reward. That means you did a good job. And these are done programmatically. I'm just explaining you the concept. Now, if my model has done something incorrect, I take this as a feedback and enter into the model as a feedback called state, and then we penalize for every mistake that the model has done. That means here the term penalization means we do some sort of a rectification in the model. So my model would be self dependent enough to take this feedback into consideration and identify that, okay, I did a mistake for which I was penalized. So let's say I have passed on an image of Barack Obama, okay, but it has told me that no, this is the image of Donald Trump. So that means the system misclassified it, and it takes this incorrect feedback and understands, okay, this was done incorrectly. So it penalizes itself and learns that, okay, an image of this attribute would comprise to a personality called as Obama, but not this one. So next time when you pass an image of this attribute or category, it would be able to classify, but the learning or the model processing of identifying correct or incorrect and then rewarding and kind of penalizing the concept is what is done in reinforcement learning. And so that's what is shown here. So you have an agent, you pass on an action, and you do an output. Now based on the action, either you have a reward or you have an observation. So when you have done it correctly, you have a reward, and when you do it incorrectly, you have an observation, which is called as, another term is called penalization. So these are the various approaches that goes into reinforcement learning. What's the best example of reinforcement learning are the self-driving cars that are being created by Google. So you might be knowing that Google has been working on making cars that can self-drive itself, right? So self-driving cars, you can see that there are certain devices that are being, vendor vehicles that are being created, or which is able to, supply doorsteps, products or goods, right? Like kind of what do I call it? I've just missed the term. Like yes, certain drone-based vehicles are being created for, Amazon is working on creating drone-based delivery, that your delivery would be sent to you by a drone machine rather than a human. So these are the various advanced version of deep learning or data science, where you can say that reinforcement learning is being happening, because when you have a self-drive car, you might be given a specific path or an axis. I mean, if you're driving on the road, your self-driving model would take this road in terms of an axis in a mathematical way, right? So that means when you are driving from here, your model is learning that that's a path. Whenever there's an obstacle, your car stops, right? Because the model is trained to identify or detect an obstacle of any sort which is coming on its path. Now let's say first time your self-driven car came 20 meters near that obstacle and stopped, whereas it would have stopped 50 meters before. That means the car came much closer. It made a mistake of, there was a difference of 30 meters. That means this model is self dependent enough to understand that, okay, an obstacle of this type, I made a mistake, I would have stopped 50 meters before, but I stopped 20, 30 meters later. So it takes this feedback in
Oh, I
loop
have a
into
question on that.
consideration. Yes, please. Yeah.
Okay, when the model makes such a mistake, so for the correction part, is that manual or is it automatic? Does the machine learning
Nothing
do?
manual. Nothing
Okay.
manual. The machine deployed in the system is capable enough to give this feedback back to the model and make it correct. That's what is called reinforcement learning, where you reward your model for a correct action, you penalize your model by observations when you do an incorrect action, and nothing happens in manual. Do you think you have a self-driven car and your car has misclassified, or has crossed an object or an obstacle, you will go and tell the car that, hey, you have to stop here? No, right? Yes, there might be a provision where your car is capable enough to take a voice input from you using speech analytics, like Amazon Alexa or Google Home, right? Or Google Now. You can say, hey, you would have stopped there. This is also one way of observation. The process of observation or model feedback could be many. It can self-learn, it can be dependent on the user, there could be various observations. So it's a pretty vast domain, right? So this is just for the knowledge purpose. So now we have covered the entire concept of DS. So if I say I have a data science, which is the world of data science, I know what is artificial intelligence. I know this is the part which is machine learning, dealing with the data, inside which I have something called as deep learning, which contributes to human intelligence and deals with huge amount of data. And then inside which is an advanced version of ML, and under the umbrella of AI, for AI, whenever I create something in machine learning, it is divided into three. We have supervised learning, we have unsupervised learning, and we have something called as reinforcement learning, which is pretty much extensively under the AI umbrella. Right? So yeah, so with this, I think, yeah, so this much was for the data science module. Do you have any questions on that?
Not at this time.
Perfect. Okay, so let me switch the deck then. So yeah, so we have then extensively spoken about the various approaches, right? So today's session, I'm going to quickly go back into the Python exercise just to kind of have a little bit of hands-on into various Pythons. So I would be sharing this presentation to you. You can go back and kind of check the concepts that are discussed. Yeah, if you have any questions, you can let me know. We can go back and discuss that specific part once again. But this is extensively covering the entire world, entire concepts of data science from a theoretical perspective. But yes, these are the things that goes into programmatic approach, when you go and hard code these things in a Python language, in any of this platform, like whether it's a Jupyter notebook or it's a Google Colab. But yes, you have to understand. So one thing you have to understand about your amount of data that you take, what sort of use case that you are dealing with, whether the size of the data is computationally dependent or computationally independent, how much computation do you might require for processing that amount of data. All these things has to be analyzed to perform a machine learning exercise. Now, the first thing that you do, apart from your, irrespective of this, is what is the use case that I have in hand. Very, very important in any ML exercise. If I give you any sort of a data, you should be able to understand that what is this data that is given to me is required to be analyzed for. What should be the outcomes that I need to pull in from this specific data that is being supplied. Now, data could be anything. So I can give you data from a medical domain. I can give you a data from the world of sales and marketing. I can give you the data from an e-commerce domain based certain customer related data. It can be anything. Every data has its own characteristics, but the way we deal it with a machine learning use case, with And one more thing is there are numerous algorithms in machine learning which we will learn in the future sessions, but identifying that for this specific problem, which is the correct algorithm that I need to use is again a tough task. Now, let's say I know about algorithm A, I need know about algorithm B, I know about algorithm C. I am taking a new problem in hand and I put applied algorithm B. Actually, this is not the best fit. There might be an algorithm E which could be doing much better on this data in order to help me to make predictions. But I don't know that E has the capability power of doing or computing or analyzing data in that pattern. So that means I lagged in understanding the basic models, the basic algorithms features. That means when this B is applied on this data, you might have a model which has an accuracy, let's say 50%. So models are always analyzed. So how do you justify that your model is doing right or wrong? What's the parameter? We use a term called as accuracy. There is a provision in Python to calculate accuracy. Okay. So we identify what is the accuracy of our model. So any model that is and there is no barrier or a threshold to an accuracy. Every model acts independently. So let's say I say my model B, algorithm B, is giving me a 50% accuracy on this data. Do you think it is sufficient? No, right? And there are other attributes that we are going to learn apart from accuracy. I'm just giving you a hypothetical scenario and a theoretical perspective that 50% is not a judgmental decision making number. Now, when I apply this algorithm E, my model accuracy, let's say, jumps to 98%. Now, this is where I'll be much impressed. I'll say, okay, that means my model is able to perform 98% correctly compared to model B, which was able to compute 50% correct, right? So any model in production that runs, let's say I'm talking about the Uber's cab allocation algorithm. So if let's say 50% is the accuracy of Uber's cab allocation algorithm, do you think it's enough for it to run in a production environment? You are able to book a cab using an app, an algorithm is running 50%. So if you're booking a cab from Florida, you might be assigned a cab which is in Washington, DC, because 50% of your model prediction is incorrect. But if the same Uber algorithm is giving 99% accurate, that means even though if you are in Florida, you have only 1% chance of getting a cab assigned to you in Washington, DC. But this 1% has also various ways to fix it. So that because Uber cannot afford to make a mistake in production, that you give a wrong allocation of cab to somebody. Right? So these are the various approaches that happens in machine learning, and exercise. So we'll quickly jump into some sessions on hands-on today. So we'll talk about something called as Lambda function in Python, which is very, very important. It's one of the very widely used functions, and it makes your work so easy. Okay, so let me just remove this annotation part. Okay, so now coming back here. So let's say I have a function and I want to add two numbers. So I say def add x comma y, and this function is returning me a value of x plus y without lambda. Now, if I call this function add and pass on two parameters 5 comma 5, it says, okay, your answer is 10 because 5 comma 5 is taken as an input of x and y, and then we add 5 plus 5 and we get 10. Okay. Now, if I pass 20 and 30, my output should be 50 because this 20 and 30 is passed to this add function x comma y, then it's doing a computation of 20 plus 30 and returning me 50. This is the function call. Now let's say I want to do the same addition operation using a lambda function. So if I want to Google and see what is lambda function definition in Python. Sorry, lambda. Okay, so it's an anonymous function that takes any number of arguments and performs an expression. So what is the lambda function? It takes any number of arguments and performs some mathematical function for you. Now let's say I want to do this addition exercise using lambda. What I'll do, I'll say add is equal to lambda, and this is the syntax. Lambda is the function x comma y. Okay, that means first value parameter is x, second parameter is y. So it is the input parameter, then a colon, and then you pass the operation, the mathematical operation that you want to do. So x comma y is my input parameter, that is this one. So lambda followed by x comma y, my input parameter, colon, I'm passing the operation that this input parameter have to undergo, which is x plus y. And then I call this add variable and pass on the value 1 comma 3, and when I run this, see, it returns me answer 4. So this add 1 comma 3 is passed on to this lambda. Okay, so 1 is assigned to y, 1 x, 3 is assigned to y, and then it performs 1 plus 3 and it gives me an output called 4. Okay, so that's how the lambda annotation, the lambda function works in Python. Okay, so now let's say I add one more tab here. I say add is equal to lambda of x comma y comma z colon x plus y minus z. So whatever values I pass for x comma y comma z, I want it to perform this mathematical operation or equation x plus y minus z, and then I'll say add of, I'll pass how many? 3 variables, 3, 5, 6, 8. So that means it will do some sort of an equation on x plus y minus z and return me the output. See, it says 1. So what it would have done, it would have assigned 3 to x, 6 to y, and 8 to z. So that means 3 plus 6 is 9, minus 8, it returned me 1. So here you can pass any form of the equation or the mathematical operation, and then before you pass on the parameters and you call the lambda function, and then in this variable, then you just pass on the values or the parameters of the number as equal to the number of inputs, the lambda function works. So if I want to do a subtraction, similarly lambda of a comma x colon a minus x, I'm passing 30 comma 20. So it subtracts 30 minus 20 and gives me 10.
Paul, I have a question on that.
Mm-hmm.
Does this lambda follow the mathematical order? Like if I had a division and an addition, would they follow the mathematical order?
Oh yes, you're talking about that rule of mathematics, right?
Yeah.
Where you have we call it as this, right? I don't know what do you call it in US, but generally over the internet we call it as BODMAS. So if you take this, that's what you're talking about. So it takes this as the concept, and then first, if you have any equation of this, it will take the portion what is in bracket, then it will take what is priority to if somebody has a power to it, then first it will do the division, multiplication, addition, and then finally it will do the subtraction. That's what you mean, right?
Yes.
So so definitely the lambda function would do this. So let me try this. So let me say x plus y in bracket. Let me pass on a here. Let's try. Okay, I haven't tried it, so it should be able to do. So that means first it will take the bracket. So it should do this first and then this first, and both these values should be subtracted from each other, right? Okay. So let's pass a value which would suit it to see the result. So let's say I pass 3 comma 5, okay, as x and y. Z is, let's say, 20, a is, let's say, 10. Now let's see what's the output. 6. Yes, it follows it, right? So lambda by default has its own computation functionality. So it would automatically actually take the mathematical operations and give you the desired output. So similarly, if I want to do a lambda operation function on a list, so let's say I have a list with this many values, okay? I want to do a lambda function, or let's say I want to divide each of these attributes by 2. And or let's say I have a list of these numbers and I want to identify that if any value in this number is an even number or an odd number. Okay, so what I'll do, if I have to do it without lambda, let's say I take list 1, and if I want to check whether the number inside this list is an even or odd, what I have to use, I have to check modulus of 2 is equal to 0 or not for every value in this list. If it is 0, then the number is even because there is no reminder. If it is having any reminder, that means the number is not divisible by 2, that means it's an odd number. So if I have to do it without lambda, what I'll do, I have to use a for loop. So I have to say for items in list 1, if items modulus of 2 is equal to 0, print items. Okay, so print this. Okay, is an even number dot format else print this is an odd number dot format. I did a syntax mistake. Yeah, so actually it should be till here. So this has to go outside the quotation. Yes. So how many values I have? 23, 45, 32, 60. So it takes each value. 23 modulus of 2 is equal to 0, because no, there is a reminder. So it says 23 is an odd number, else got executed. It took 45, again it performed the operation, modulus not equal to 0, it's an odd number. It took 32, okay, it says 32 modulus of 2 is equal to 0, it got true, so it printed this number. That 32 is an even number. So like this, I did it for all without any lambda function. Generally, if you don't know the lambda function, it doesn't mean that you cannot work in Python. You can still work in Python. Like this, you write a generic loop. Now let's say I want to convert this same using a lambda function to make it easier and reduce my lines of code. I'll do list1 is equal to this. So I'm creating a final variable called final list, where I'm saying that this final list will be a list of all the even numbers. So where I said, so let's say I rename it as list underscore even. That means from this entire list, I want to create a sub list with only the even numbers. Okay. So I'll say list underscore even. Okay. So what I'll do, list even is a variable for which I want to create a list. So list is a method also. If anything that comes in green here, it's a inbuilt method in Python. So list of filter. So filter is again a method that I'm calling here. Okay. See, this is an advanced way of Python. This is the basic way of Python. So one exercise can be done in various ways. Somebody who is a beginner in Python would do it in this way. Somebody who's like 15, 20 years experienced in Python, and you give him this list to identify even or odd number, he will write it in one line itself. That's how experience comes into picture, right? So he will say, I'll create an even list where I'm creating a list. I'm filtering this entire list with the lambda function. So what he did inside this filter function, he has created a lambda of x. That means x will be looping through each of these values, where it will check if x modulus 2 is equal to 0 in where list 1. Wherever it suits this condition, that value will be stored in a list, and I'm getting it in a reverse value list called this list even. and then I'm printing it. See, I'll get the same result. So it took 23. Inside this lambda function, it did not find 0. It was a reminder. It did not take this value because this condition was false. So whenever it satisfies this condition 32, this 32 satisfied this condition from list 1 when I'm filtering. So it added it and created a list which got saved into the list underscore even, and I'm printing it, I'm getting it the value. So this is how you can do an advanced programming. So let's say you are giving an use case, you have written a line of code, you have written a logic which is of 200 lines. Bob has written a logic which is of 50 lines. Now where is the difference? So what he did, what multiple operations you did line by line, okay, he did 5 steps of your into one single step because he knows Python better.
Hey, Paul, I have a question.
Please go ahead.
After lambda, where he used x, how come he did not use list 1?
No, so this is the format of lambda. So lambda takes the parameter first, input, after colon it takes the operation. That's what we learned above, right? So for lambda, it passed on the value input x, which would be looping through which would be each of these value, colon. For this value, what it has to do? So if it picks 23, it will say lambda x colon 23 modulus of 2 equal to 0. This is your lambda. That's all is your lambda which we learned above.
Yes.
Now to perform this lambda operation, where he will go and find the x? He will go and find the x in list 1, which is a part of your filter function.
Okay, I
so
see.
your filter function takes first the mathematical operation input and then takes the destination from where it has to put the value. So actually lambda function is from here to here. So it is a combination of 3 methods: lambda, filter and list, all 3 combined together in one single line.
Okay.
So my lambda is here to here. It is taking x colon the operation. Similarly, it took ax colon the operation. It took x colon x minus modulus 2 equal to 0. But now this is lambda done. Now I have to use this lambda inside a filter function where, let's see, what does a filter function takes in Python? Filter method in Python. Or what else you can do here is, I think that will also work. I can open it here and I'll say filter.help. Okay, filter is a method, it does not. Okay. Shift on. Yes. So in Jupyter also, if you want to know what does a specific method takes with it, write the method, and if you hit on Shift tab in your laptop, keyboard, it will tell you that what is this inbuilt what is this method is all about and what are the parameters you need to pass. So it says that for filter, it takes a function or anything or none. Either you can pass a function or anything and then an iterable value. So if I go to filter here, see, it takes, what does filter take? It takes a function followed by an iterable value. So my function was actually the lambda, and my iterable value where I have to iterate through each and every value was my list. So that's why if you see, this syntax would justify. So filter has taken the function first, which is the lambda, and then followed by comma the iterable object. My iterable object is list1. So this function should be executed where? So this is the function iterable to be applied on list1. So this is my filter, and this entire filter I have binded into a list, which I'm saving it into a list underscore event variable, which I'm printing. Clear?
But how come we did not define what x refers to in the lambda function?
You don't need to define anything in x.
Okay.
We learned this there. Did we define what is x here? Whether it's an integer or value, whether it's a, we learned this last time, right? If I say x is equal to 3, and I want to see what is x, Python itself is self-dependent to tell me x is 3. In Python, we don't have any explicit allocation of variable. So whenever I pass x within lambda, that means lambda will take care of x itself. So lambda will take x from where? It will now go, lambda will reversely call filter, because this is the function. Now filter will tell, okay, you have x, go and apply it on list 1. So it takes the first value 23 and divides it with the logic. And once the output is x is true, it will save it in a list underscore event, which is 32. But for 45, this condition failed. So it did not save it into the list object, where list event does not have the 45 value.
Oh, got you. So, okay, now I got it.
Okay, so that's where the benefited in Python you are. You don't have to mention explicitly. You're in. That's what the see here. I have written the logic myself. I have to loop through each values of list 1 and then give a print statement and do it like this. But if I do it in a little advanced way, the benefit of utilizing this inbuilt method is to reduce the number of lines of code. But it is a little tough for somebody to understand at the beginning who is very new to Python, like you had a doubt. But when you do more work on Python, okay, you will be also starting to understand when you get more hands on that. How do you combine multiple lines of code into one single line? This is also possible. Okay. Okay. So, yeah. So with this Lambda function, yeah, I think we are good today for the day. So tomorrow we're going to talk about certain I don't want to make it heavy for you, because the next two concepts you need a fresh mind. So tomorrow we're going to touch solely on something called as NumPy and Pandas, which are very, very important. You can say bread and butter for you to work on any machine learning exercise. You have to know what are Pandas and what are NumPy. So I think the link that I have shared, you would have learned a little bit about the NumPy and Pandas, correct?
Yep, I went through the video.
Okay, perfect. So what we will do is tomorrow we will start with a little bit of a refresher into NumPys and Pandas. We will refresh the concepts. We'll do some hands-on in a Jupyter notebook, and then from probably next week onwards, we will get into certain deeper concepts of machine learning. I have to see the abstract, and we will have a little more into supervised learning. We will learn about the algorithms and all those things. Okay.
All right.
All right then. Any questions for today's session?
No, I have none.
Perfect.